Alright guys, so this is 16.48, and it says, oil explorers set off explosives to make loud sounds and then listen for the echoes from underground oil deposits. Geologists suspect that there is oil under 500 meter deep lake physics. It's known that lake physics is carved out of a granite basin. Explorers detect a weak echo of 0.94 seconds after exploding dynamite at the lake's surface. If it's really oil, how deep will they have to drill into the granite to reach it? All right, so to start this problem, I'm going to start with the picture to help explain what we want and what we know. So basically we have a lake here. This top line is the surface of the water. And then some distance in the lake, or 500 meters deep into the lake, we have a granite floor, which is this line. And then past the granite floor, a certain distance, which is unknown, we have a supposed oil deposit. So basically what we want in the problem is we're looking for the depth of the granite, or the distance between the surface of the granite and the oil deposit that it's hiding. And we know, / are given, we know the depth of the water, we know the lake is 500 meters deep, we know the speed of the echo through water, and we know the speed of echo through granite, the speed of sound through granite, and the speed of sound through water, which is just known information. And then we also know that velocity is equal to distance over time. Okay, so to start this, starting from velocity, the equation velocity is equal to distance over time. So let's try to break this down. So we know distance in this case is going to be equal to the distance that the sound has to travel. And since it's an echo, the echo has to go, or the sound has to bounce off a surface and then return to sender. So knowing that, we know that distance is going to be actually twice the distance of the medium that the sound is traveling through. So for water specifically, velocity is going to be equal to twice the depth of the water, because again, the sound has to bounce off the bottom of the lake and back up. Divided by time, in this case is going to be the time in the water, and that gives us velocity in the water. We can rearrange this for time, giving us this, and we can do the same thing for the sound through granite. V granite is equal to 2 times the depth of the granite divided by the time in the granite, and we can rearrange this and isolate for time granite. And the reason why we're isolating for t here is because this allows us to sum both the water term and the granite term into this equation, this larger equation. So again, since the sound is traveling through both the water and the granite to get to the oil deposit, we have to add both of them. And I think this is the biggest pitfall with this problem, at least for me, was that this is not like coming to this knowledge that you have to add them together is not as simple as just breaking down something like this into known values. So yeah, basically the sum of the times is equal to the total time in this case. So we have everything we want in here, and everything we know, and only things we know. We just have to isolate for what we want. So doing that, skipping some algebra, we have this equation. The depth of the granite is equal to the total time minus twice the distance of the water over the velocity of water, multiplied by the velocity in the granite, or the velocity of sound in the granite, over 2. And yeah, so this is the answer. We know it's an answer because we have what we want, the depth of the granite, written in terms of only things that we know, all this stuff. So yeah, you would just plug in known values like so. So after plugging all those values in, you should get about 792.97 meters. As far as context of the problem, I think the problem is just trying to get you to understand how echoes work, or how sound waves work more specifically, and how you can manipulate the speed of waves and whatnot to find unknown values regarding them. Thanks for watching, guys.